Roses. Well, I know we're both beyond use. Don't make no.
Okay, here's problem number 3, the final problem for our practice problems video. This is our ODE, our given ODE here, and on this problem I'll use a variation of parameters, which was the alternate method given for solving linear equations. So the first thing I want to do is just divide the whole equation by 1 plus x to the third in order to get this away from the y prime, right? So we're just going to end up with y prime is equal to, then we have 3x squared times y over this 1 plus x to the third plus, and this x squared plus x to the fifth, we can actually factor out an x squared, so we get 1 plus x to the third. When we divide that, we get 1 plus x to the third, so those cancel out nicely, right? So we can rewrite our equation effectively as y prime is equal to 3x squared over 1 plus x to the third times y plus an x squared. Okay, so remember, we'll recall from variation of parameters, what we're going to do is solve the associated homogeneous equation first, which means we're going to kind of focus on this one part here. Okay, so this is like, we're just going to solve that and find our solution to the homogeneous, which is y sub h of t. Okay, so let's do that on the next slide. So we have y prime is equal to 3x squared over 1 plus x cubed times y, and I'm going to rewrite this part as dy dt is equal to, no, well, not dt, sorry, well, okay, we're dealing with x's here, so dy dx is equal to 3x squared over 1 plus x cubed, and then times y. So this is a separable equation, right, because any homogeneous equation is separable. Alright, so anyways, so now we're going to just divide that over, so 1 over y dy is equal to 3x squared over 1 plus x cubed dx. Okay, so now we're just going to integrate on both sides respectively, so we get ln of y is equal to, and then when we integrate this, we can do u substitution, so u is equal to 1 plus x cubed. This will be a nice u substitution, it's already pretty much set up for us, and I'm messing up that 3, there we go. Okay, and du is equal to 3x squared dx, so we can replace those directly. So we just get, this is the integral of 1 over u, and then du. Okay, so now we have that this is ln of u, which is 1 plus x cubed. And then we have our plus c there as well, but we're not really going to deal with that as much, okay? Because we could just set that equal to 0, basically. All right, so when we do this, and we're going to solve for y now, so we kind of just ignore this middle step, okay? So we're just going to exponentiate both sides, alrighty? So we get y of x, or this is the homogeneous one, solution, is equal to, and these cancel out, so we just get 1 plus x cubed, okay? And then we'll recall that our actual solution to the original ODE is equal to some unknown function of our independent variable times the solution to the homogeneous equation, right? So now that's what we're going to use in the following steps, okay? So just keep this in mind, and we're going to keep this in mind and construct our solution. All right, so we have y of x should be equal to some unknown function of x times the solution to the homogeneous, which was 1 plus x cubed, right? So now that we have something like that, we're just going to plug it back into our original ODE, which was given by y prime is equal to 3x squared over 1 plus x cubed times y, and then plus an x squared, okay? So now that we have that, we're just going to differentiate this whole thing in order to get y prime. So when we do that, we get v prime of x times 1 plus x cubed, okay? And then plus and now we're going to differentiate that, so we get 3x squared over, over 1. But anyway, so 3x squared times this v of x, okay? And that's so that's the left side. This is when we differentiated y once. And then this is going to be equal to, according to our ODE formula, 3x squared over 1 plus x cubed. And then y, we're just going to plug this directly in. So we have our v of x times 1 plus x cubed. So we see that we can do some cancellations later on. And this is plus x squared from the formula there. Okay, so when we cancel those out, we just get 3x squared times v of x, which we see the same thing on the left side, so we can just cancel those out because we just subtract those on both sides. So we're left with v prime of x times 1 plus x cubed is equal to x squared. Now we'll just solve for our v of x by dividing by that quantity on both sides. So it's equal to x squared over 1 plus x cubed. Okay, and when we integrate with respect to x on both sides, we just get v of x is equal to, and then we're actually going to end up with something like this. Well, we can do u substitution, so 1 plus x cubed du is equal to 3x squared dx, and dx, for the purposes of direct substitution here, we're just going to divide by that, okay? So we just get, this is the integral of 1 over u, and then our x squared we can't do anything with, but dx we can replace with du over 3x squared. So the x squareds cancel, right? And we just get this factor of 1/3 out in front. So 1/3 times the integral of 1 over u du. So this is equal to 1 over 3 times ln of the absolute value of u, which is 1 plus x to the third. Okay, and then plus a c, plus our constant c that we can't forget about. Okay, so here is our v of x. That was our unknown function, which is now known. So we're just going to plug that in for the final step, and I'll do that on the next slide. So our y of x was equal to v of x times 1 plus x to the third. But now that we know our v of x, then this will be y of x is equal to 1 over 3 ln of 1 plus x to the third, and then plus our constant c, okay, and then times this 1 plus x to the third, and that is our general solution, and that was using variation of parameters. Okay, that wraps up our practice problems video for section 2.4 on linear equations. I hope that helps, and good luck on your homework.